Okay, as we can see with this one so far, there's been no change in this one, and it's still got bubbles in there. It seems to retain the bubbles at night time as well, when there's not so many bubbles being generated, if at all. These ones so far, even with the one with the phosphorus in, no sign of greening at the moment, so that's strange. So that's definitely different from that, which did it in about 24 hours. But if you notice with that one, the green doesn't seem to see, the intensity seems to be almost consistent. Like, as I said, maybe there's something that's, as soon as the green is produced, assuming it's some sort of algae or something, algae, it's been consumed or something, and maybe that's how the red organism is formed. First of all, maybe it's in a colloidal, translucent, transparent stage, and then it goes red later on. I don't know. Maybe it needs a certain element to go red, so if there's not enough of that element in the water, and maybe that element is basically found in charcoal, that's the only regular form it's found in. I don't know. Probably mere and pure speculation there, but you know, this one's different. This was the other copper salt one we set up, and it's losing its colour, sort of thing, but it's not. Doesn't look like it's going. And there's a little bit of precipitate on the bottom. I don't know if you can see that, but not as much for the amount of copper we put in there, so you can't really just say it's copper hydroxide or copper carbonate or something like that, because usually when you get a precipitate, it's always larger in volume than the actual amount you put in, usually as a general rule for a precipitate. So that's a bit strange as well. So one, the colour's wrong. Two, it is fading, which is strange. So is it sticking to the interstices of the polystyrene? But in a form that's going to be translucent eventually, which is, again, weird in itself. So I'm just going to, wait on that one for a while before I set up any popcorn, just to see things may be a little bit different. Now, come back here. This one here, I'm just setting up a general control. It's just going to be a bottle of polystyrene and ammonia, and a known quantity of phosphorus. My favourite form of phosphorus at the moment, or in general for CPs, is I don't know if you can see that, but check that it's in the screen. It's superphosphate. There are a number of brands and they're different. I like it because it's, if you can see that, I don't know, is it going to focus? Hopefully it's going to focus. Can't tell, fellas. Okay, it's all blur in the back there. It's got, basically, it's 10% total phosphorus, basically, that one there. So there's a reason for things like that. And whether I can actually make myself a super borate, I don't know, and try that out eventually. But yeah, so basically I'm just going to put this cloudy ammonia into that bottle, and a known quantity of our phosphorus, and basically, if you look at it, it does contain calcium, which is strange, isn't it? Yeah, it's strange. And another inconsistency for CPs, seems to be quite a good form for carnivorous plants as a phosphorus form, but it contains calcium. Another inconsistency. CPs aren't supposed to like calcium. Have to work on that one, fellas, won't you? You're all full of inconsistencies. Well, I think that's where, Einstein says that's where all the science is, where you have the incongruencies and inconsistencies. Now with this one, keep it in a jar like this. It's very stable, even with lots of salt in there. It doesn't change. Normally, if you had copper and salt, it would go green, but with all this salt in there, no, it's quite stable. And it's quite stable when it's damp. I had some of this I made in my early teenage years in the early 1980s, and I had it for 30 years, and even in quite a warm shed. As long as the lid's on and you keep the moisture content up, it's quite stable. Other thing here, if you mix this is your charcoal sort of thing. I put it in a bottle, and if you put ammonia on charcoal, slowly over time the ammonia will disappear. But unusual. Charcoal's unusual. Charcoal's a bit like polystyrene, paraffin wax. It has unusual properties. It has the ability to pull the pH in from both ends. So if you have an alkaline solution on charcoal, it will become less alkaline. If you have an acid solution on charcoal, it will become less acid. So it sort of pulls it in from both ends. So like, in a way, like two opposing magnets in a way. I don't know if you want to make that sort of analogy, but so basically that's it. I'm going to fill that up with more polystyrene. See, polystyrene and paraffin wax have got very interesting properties. They have basically a neutral pH. If you get the right polystyrene, most polystyrenes are new, but you occasionally get one where they haven't made it properly or something like that, or they put something else in it and it's not neutral. But quite a lot of the polystyrenes, if not all of them, that you tend to, well, at least find in southern Abbott land anyway, tend to be in neutral in pH sort of thing. And they seem to have this amazing ability of reacting with water, and I suppose we're going to have to explore other polymers, and maybe things like acrylic, rayon and things like that, things you can get in the shops as balls of wool and things like that. But I think that's about it for that. I think I've gone through my whole spiel very quickly. I didn't expect to go through my spiel that quickly, but anyway, so this is a very, very short Christmas video special clip. Lots of information in it. Okay, over and out, see you.